Hi everyone, my name is Daniel Roth and I'm a program manager on the ASP.NET team at Microsoft. And today we're going to build some web APIs using ASP.NET Core 2.0. This is an introductory session, so we're going to walk you through step by step how easy it is to build web APIs that can be used by a wide variety of clients, including browsers and mobile devices. Let's get started. So first of all, if you haven't already, you're going to want to go and install .NET Core 2.0. So go to .NET/Core and install .NET Core 2.0 for your platform of choice, Windows, Mac, Linux. That will include ASP.NET Core 2.0, so that's really what you need. So go do that right now if you haven't already done it. Next, you should get Visual Studio. So go to visualstudio.com and install the Visual Studio flavor that works for your platform, Visual Studio for Windows, Visual Studio for Mac, or if you prefer a lightweight text editor, I recommend Visual Studio Code. It's great. All right, so to get started with building web APIs, let's first understand what is a web API. Well, a web API is an HTTP service. It's some logic or some data that you want to be accessible over HTTP. It's an HTTP resource. Web APIs are typically intended to be used programmatically. They're intended to be called as a service from code, from software. And the really cool thing about them is they're APIs in the sense like you have APIs in a library, like if you're writing .NET code in a DLL. But these are APIs that can be accessed across the internet. Because they use HTTP as the language that you use to talk with a web API, pretty much any device, any platform can now consume that API. It could be Java, it could be Python, it could be a little tiny watch. Doesn't matter. Pretty much every platform has HTTP. So web APIs give you that broad reach. Now we're going to be using HTTP a lot to build our web APIs, so let's do a quick HTTP refresher. HTTP is an application layer protocol, so we're going to embrace it. We're not going to try to ignore it through abstraction like you might a transport layer where you really don't want to know the details. With HTTP, we want to get our hands dirty with all the artifacts of HTTP. Headers and the body and formats and status codes, methods, all those things. Now, with HTTP, you're interacting with resources. You're accessing resources, and those resources are going to be identified by a URI. The host part of the URI will indicate which server that resource is hosted on. The HTTP scheme indicates that you're going to talk to it over HTTP. Then the path is going to represent the logical resource that you want to access. And that's going to be important because we're going to see that that path is the primary construct we'll use for routing requests to whatever logic it is that you want to run in ASP.NET Core. The query string parameters provide additional considerations about which resource you want to talk to. Now, the cool thing about HTTP is you access these resources, you interact with them using a standardized set of methods, or sometimes called verbs. This is different than when you write like a code-based API. Code-based APIs, you write functions and classes, and the semantics of those functions and classes can be pretty much whatever you want. In HTTP, the semantics are standardized. So a GET request is how you get a resource. And you should be able to do that over and over again without any unintended side effects. Post requests, that's how you do some action on a resource. Often that action is you want to create a new resource. Post actions are really flexible. You can do pretty much whatever you want with them. A put request is you want to take a resource and put it at a specific URI. Put this here. If that resource doesn't exist yet, it could mean creating that resource. If it already exists, it's effectively an update where you're updating the resource wholesale. Like GET requests, you should be able to do a put request over and over again, and it shouldn't have any unintended side effects. That property is called idempotency. Delete requests, you want to remove a resource, and so on. There are a bunch of HTTP verbs. These are probably the ones you most frequently will interact with. So you can create those CRUD operations, create, update, read, delete. Now, HTTP is a stateless request-reply protocol. So you have a request and then a reply. And you don't need to really remember anything in between each request. That makes it so that you don't have to hold on to any state, makes it easy to implement, makes it easy to scale. Now, each request and reply has headers, which is metadata about a body. And the body can be anything. This is one of the beautiful things about HTTP is formats. You can put pretty much whatever you want into an HTTP body, which means your resources could be anything, and they could have a whole variety of representations. They could be, JSON data, XML. They could be images in a variety of formats, JPEGs, GIFs. They could be videos, they could be PDFs, any format you can imagine, and you can create your own. That's one of the really nice things about HTTP. You're not constrained by format. When you get the response back, the response has a status code, and that's important as well, because the status code tells you what type of response was that. Status codes come in 5 basic groups. The ones that are most relevant to web APIs are 200-level status codes, first of all. Those indicate some sort of success, like the request was successful. It was received, it was understood, it was processed. So for example, 200, OK. That means, yeah, success. We got your request and we processed it. You might get that in response to a GET request to actually retrieve the resource. That means you successfully retrieved the resource that you wanted. 201 is a created success response. That means you tried to create a resource and it was successfully created. And that response also probably contains some information about where that resource was created, like a location header that tells you the URI of the newly created resource. What else? So 400 level status codes. Those indicate something went wrong and it was the client's fault. So for example, a 400 bad request response. That means that something in the request couldn't be understood. It had bad syntax, so it was a bad request. A 404, like I have in my t-shirt, that means that the resource you requested, it's not there. Like you gave me a URI and there's nothing there to actually retrieve or to interact with. 401 might mean that you don't have the credentials, you haven't been authenticated to actually access the resource, and so forth. Those are all client problems. 500 level status codes, that's a server problem. Something went wrong in the server. So for example, a 500 internal server error, that typically means that, like in a .NET application, some exception was thrown and it was unhandled, and the server says, sorry, something went wrong, contact your administrator. So we're going to be using those status codes, and it's important that we carefully implement the semantics of HTTP so that we play nice with the web, with features like caching, for example, or proxies. If we correctly honor the semantics, those things just work, and you get all the benefits of internet scale. Now, ASP.NET Core is an HTTP stack. It's an HTTP framework. It's built to allow you to receive and handle HTTP requests. It has a server which listens for HTTP requests from the network. The server that we most typically use in ASP.NET Core is called Kestrel. It's a very fast, very small, cross-platform server. There are other servers you can use as well with ASP.NET Core. You could use HTTP sys on Windows if you're running on Windows, or you could be running behind IIS. So Kestrel, the server, will listen for the requests, and then it will invoke your middleware pipeline with each of those requests. Your middleware pipeline is all the stuff that you want to happen when a request comes into your application. When you use MVC in ASP.NET Core, MVC can then route those requests to a specific controller, a class, with an action method, a method on that class. That's where you then write your code, that's where you write your logic, and set up the response that you want to be sent in response to that request. The response then flows back down the middleware pipeline and gets sent back out by the server, and that's basically it. So, to create our web APIs with ASP.NET Core, we need to do 4 basic things. We need to create our ASP.NET Core project, get the server up and running, listening for requests, get our middleware pipeline ready to go so we can start fiddling with it. We're going to add MVC to our application, to the middleware pipeline, and add all the MVC services so that they're available through dependency injection. And then we need to create our API, our code. So we'll create a class that will be a controller that we can route requests to. And that class needs to derive from, well, generally will derive from controller base when you're implementing a web API. And then you implement your action methods on your controller to determine how you want to, which requests you want to receive and how you want to respond. And that's it. So let's do it. Let's build our first web API. All right, I'm going to switch over to Visual Studio. Let's do File, New Project. I've already got .NET Core 2.0 installed, got Visual Studio installed, so I have my ASP.NET Core web app template. Let's go create one of those. And I'm going to start with empty. I could start with, there is a web API template that has the stuff that I'm going to show you how to set up already set up for you, and that's great. But it's kind of nice to be able to see the steps. So I'm going to start with empty and show you just the simple pieces you need to do to get web API up and running in an ASP.NET Core app. All right, cool. So now we have essentially a bare bones empty ASP.NET Core app that can receive HTTP requests and send responses. If we look at our startup class, which determines our middleware pipeline, you can see there's hardly anything in here. There's some development middleware, the developer exception page, which if there's any exception that occurs, that will print it out to the screen in a friendly way. Basically, those are the 500 cases. And then we have a little inline middleware that just returns a static string. Let's just make sure this guy is working. So I'm going to run it. And we should just see hello world in the browser in response to any request that we send. All right, cool. So that looks like that's working. All right. Let's now add our web API. So I'm going to go back to the app. And first thing we got to do, remember, is we got to add MVC. We want to set up MVC in this application. MVC is not set up yet. So let's do that. So first I'm going to add the MVC services. Services.add MVC. Great. And then now let's use MVC in our pipeline. So app, actually, let's leave that middleware there. And we'll just put MVC before it. We'll do app.use MVC right here. And we'll say, we'll put here like MVC was not used, or yeah. MVC didn't find anything, I guess. That's what we'll put here. So that means that if we see that message, we know that MVC wasn't able to route the request anywhere. And that's what we should see now by default, because there's no controllers for MVC to route to. If I refresh the browser, yeah, MVC didn't find anything. OK, good. Now, let's add our API. So I like to put all of my controllers into a folder, so they're all in one spot. So I'm going to create a new folder. And then let's add a class. And that class needs to be a controller class. So typically, it derives from controller base. We do have a nice item template that you can use for that. Web API controller class. So let's use that. Values controller sounds good. And we'll add that to our application. Now, as you can see, this class is a class that this currently derives from controller. Now, controller is the base class in MVC that you use when you're doing anything. Like if you want to do UI, like return views, doing the full model view controller pattern, you derive from controller that allows you to render HTML. And it has all the web API helper methods on it as well. But it's pretty much overkill for what I'm doing today. I'm just building an API. So I actually recommend, if you're just building an API, controller base. And that will reduce some of the IntelliSense noise when you're trying to find the right result to return from your action methods. OK? And it looks like we have some methods here. Looks like, based on the comments, this one will respond to GET requests to API/values. And it looks like it just returns an array of values. And then we have another one where I can get a specific value. OK? And it looks like that one just always return value. Let's actually update that. Let's make it return not just value, but let's actually return the ID along with it so we can see that that's working. All right, and then we can receive post requests and put requests and delete requests. Those guys don't currently do anything, but we'll fix that in just a little bit. OK, so let's see if we can access our API. So it says I should be able to go to API/values. So let me go to API/values. And do I get to my web API controller? I do. And in fact, that array values got serialized as JSON for me just by returning it. So that's cool. Can I access an individual value? I can. And I can even see the ID that I specified in the URI is being passed through. And we'll talk a little bit more later about how that works. All right, cool. What about the other action methods? So we have action methods for post, put, and delete. Now, those are a little harder to test in the browser. Browsers typically send GET requests. They can send post requests if you set up a form. I don't want to build a form right now. So instead, what I'm going to use is a simple little tool for sending HTTP requests to my API so I can see that those actions do actually work. The tool I'm going to use is a cool little tool called Postman. It's great. You can get it at getpostman.com. It's a free community tool, and it's pretty nice. So it's great for doing web API development. And there are a variety of other tools out there you can use as well. All right, so I have got Postman installed here. And what do we want to do? Let's try to do a post request. To see that it's actually getting hit, I'm going to actually now run in the debugger. And let's set some breakpoints on these actions, and let's just see if we can get requests sent to those particular action methods. All right, so let's put a breakpoint on post. Let's put a breakpoint on put. And let's put one on delete. OK, so it says I should be able to do a post request to API/values. And it looks like it's going to take some string value out of the body. All right, cool. So let's try and send a post request. So let's do post. Let me copy the URI. And let's go here. And API/values is what I need to post to. If I send this just as is, what do I get? Oh, I got some sort of error. 415 unsupported media type. What does that mean? Well, that's the client-side error. So, the client did something wrong. I did something wrong in Postman, where the request I sent had some format that the server didn't understand. It's like, I don't understand that format. If we look at the body of the request in Postman, we can see that by default, it tries to send form data. We can even look at the raw HTTP request and say, yeah, the content type header is saying this is, form data. Now, that post action isn't set up to handle form data. It's got that from body attribute on it, which basically means it's expecting JSON, something that it can that its formatters can handle. We'll talk more about formatters in a second. So I need to actually send this guy JSON for that to work. So there's those status codes, helping me understand what's going on with my API. So I'm going to switch to this raw view and select text. Let's go to JSON, and let's actually send now a test value in JSON. And this, hopefully, should now work. And yeah, now I'm hitting my post action. It doesn't do anything, so we can just let that go through. But at least I know that it's working. Similarly, we can try a put request. If I put a value to values 1, 2, 3, I believe put requires an ID and also something in the body. All right, so let's do that. If I send that, there, we hit our put request. Let that flow through, and we can send a delete request. If we wanted to remove a resource, delete requests can have something in the body, but I don't think this action is expecting anything. It's not. So let's send that, and yeah, we hit our delete request. All right, so there we built our first really simple web API. All right, let's talk about now how those actions routed. How those requests were routed to those particular controller actions. Oh, I see I have a question. The question is, why not use API controller class? So that's a great question. If you're familiar with ASP.NET, ASP.NET has a wide variety of frameworks. There's MVC and Web API and Web Pages. In ASP.NET Web API, there was a base class, an API controller base class that you would typically derive from. I'm using ASP.NET Core. ASP.NET Core really tries to unify all those different frameworks that we had in ASP.NET into a single aligned stack that handles both Web UI and Web APIs. So when I say I'm using MVC in ASP.NET Core, that's really the infrastructure for handling controllers and actions and routing. And that infrastructure now is exactly the same whether you're building some, using some Razor and generating some HTML, or if you're building a web API that returns some JSON data. So the base classes that you use are fundamentally the same. Now we do have a compatibility pack for ASP.NET Core, a web API compatibility pack, which sort of puts a facade over ASP.NET Core so that it looks like ASP.NET Web API. Like it brings back an API controller base class. It brings back some of the API patterns that ASP.NET Web API used to have. So if you like that pattern and you like having an API controller base class, you could try that out. You could also define your own API controller base class. But for most ASP.NET Core development, you don't really need it because the controller base already has all that stuff that you would want. So that's why I'm using that as a base class. Okay, let's talk about routing. How did that request actually make it to those action methods? Well, routing is the mechanism that's used for doing that, and it's done. You specify your routes typically for APIs using attributes, using attribute routing. So first of all, attribute routes actually serve two purposes. They constrain which HTTP method or verb that you want those action methods to handle. Like, is this for gets? Is this for posts? Is this for deletes? And then second, they provide a route template to a pattern that should match before that the URI should match before any requests actually make it to that action method. So typically those things are specified together. You have an HTTP get attribute, and you put the route template right there. Now, if you want to have an action method that handles multiple HTTP verbs, that's possible. It'd be tempting to just put multiple HTTP get, post, put, delete attributes on that action method, but that actually doesn't work. They are constraining the verb. So if you put two constraints, one that says it has to be get, and the other one says it has to be post, well, you're not going to get anything. So instead, you need to use the accept verbs attribute, which allows you to specify multiple verbs, and that will work. If you don't want to specify any HTTP verb at all, and just say, this is just the route, I don't really care what the HTTP verb is, or I'm going to specify it some other way, then there's also a generic route attribute that allows you to just specify the route template. Now you can put route attribute routes on both the controller and on individual actions. When you do that, the routes on the controller are prepended to the action route. So if you have like a common base route that all the actions are using, put that on your controller using like the route attribute, and then you only need to specify the delta on each of your individual actions. Now, route templates have some really nice features, some interesting syntax. First of all, if you want to actually extract some data from the URI, you can specify that in your route template using brackets. If you put a name in brackets, that part of the URI will then get captured and made available to you in the framework. So for example, here, API/order/brackets ID, that brackets ID is a route value. If that path segment essentially will get captured and made available to you as a value named ID. Now, route tokens give you a way to have parts of your route template that you actually want to be based off of your controller, action, or area names. So for example, in my values controller, I generally want my routes to start with API/values. But if I refactor my value controller type name to something else, I don't want to have to go through and fix up all my routes necessarily. So using square brackets, you can specify a route token that will get replaced with the corresponding controller action or area name. Now, if you want your route values to be optional, like if they're there, great, capture it, but if they're not, it's okay. It should still match. You can specify a question mark that expresses optionality. If you want the value to be optional but to have a default value, you can use equals as a syntax. So ID equals latest means if the ID is there, capture it. If it's not there, it's okay, but when I ask for the ID route value, please give me the value, this default value, latest. You can also put constraints on your route values using colon syntax. For example, if you want the route value to be of a specific type, or if you want it to match a regular expression, you can do that using colon. So ID:int means that this route value only should match if the value is actually an integer. Otherwise, the route shouldn't match at all. All right, let's take a look at some attribute routing. All right, if we look at our values controller, first of all, at the top, we can see that we have a route, an attribute route specified on the controller type itself. And it's just a generic route attribute that specifies the base API/square brackets controller route template. So that means that all the requests to this controller pretty much should start with API and then the controller name. Remember, square brackets is a route token. That will get replaced with the controller name. Now, the controller name will actually be the name of the type without the controller suffix. So you can ignore the controller suffix. So the name of this controller is just values. And we saw that worked. If I were to rename, let me stop debugging so I can edit some code. If I were to F12 and rename values controller to, I don't know, stuff controller, all right, and say my controller is stuff, I rerun the app. OK, if I go to API like I did before, MVC didn't find anything, so the route has changed. If I go to stuff, aha, now I'm back at my action method. So that way of defining your route templates is robust to refactoring gestures. If you find that undesirable, like you don't want your routes changing just because you renamed your class, that's fine. Just go ahead and put whatever you want the route to be in a stable way right there as a string, and you're good to go. All right, let me change this back so I don't forget. So Voller is what I'm going to use for the rest of my demos. OK, now we look at the individual action method. This get action has HTTP GET action. It's constraining this action to only receive GET requests. It doesn't have any information, which means it's only going to use the route information from the base controller. So API/values, you issue a GET request at that URI, it's going to end up here. Next GET action does have a route template. So this is also constraining the verb to get, but it has a route template, and this is value ID. It's saying, I would like requests that go to API/value that I'm going to call ID to go here. And you can see, flow that value through to the actual action method. We'll talk in a little bit about how that works. All right, post, again, just using from the controller. And then put and delete, also like with an ID, are specifying an ID of the specific resource that they operate on. Okay, great. So now let's play around with a few things. I'm gonna comment out this first action just so we don't get any accidental overlaps of the. Let's play around with this get action right here. So if I want this ID to be optional, I can put a question mark next to it, and that means that if the request comes in and it has an ID, it should match and capture that ID. If it doesn't have an ID path segment, still okay. They'll end up here. In that case, I think we end up with a default value for the integer. Let's try it out. So if I do API, let's go back to values, and I do 1, 2, 3. So I've specified the ID path segment. I should get value 1, 2, 3, and I do. But if I don't specify it, it still routes that action. It just gives me the default integer value. Okay. All right. What if I actually want to control what that default integer value is? One way you can do it is right in your route template. You can say that I'd like this ID to be optional, but if it's not specified, then I would like the default value to be 321. Okay, so now if I do this and go to 1, 2, 3, I should see value 1, 2, 3. I do. If I don't specify the ID, now I'm getting that default value. Okay? Cool. All right, and then lastly, what if I want to constrain this route and say that this route should really only hit if that ID actually is an integer? Let's switch it back to what it was originally, and if I do, 1, 2, 3, I should be working again. Let's see, value 1, 2, 3. Is it going to come up? Yeah. Okay. But if I do like ABC, well, that will hit because there's an ID there. It'll get captured, but it's not an int, so it won't be passed into the action method. Instead, I'm just going to get, the default value of integer, I think. Let's see. Yeah, and I get 0. What if I want, I don't think that action should even hit at all if it's not an integer. Well, you can do that using what's called a route constraint. And you do a route constraint, use this colon syntax, and I can say this has to be an integer. All right, and if we do, now let's go back, let's try 1, 2, 3 again, just to make sure it's still working. It is. And now if I do ABC, this should not hit, and we should fall through. Yeah, and we do. It's like MVC didn't find anything to route to, and so we end up with that default message. All right. Next, I think that's it for routing. I think let's move on. All right, so how does the data from the request actually flow into your action methods? We've got the request now at the right spot. How do you get data out of the request? Well, in ASP.NET Core, the underlying primitive of everything that you do with regard to HTTP is done through HTTP context. HTTP context will give you access to the raw headers. It'll give you access to the body, and you can party on the request and response however you'd like. But when building a web API, MVC gives us a bunch of features that makes dealing with request data a lot easier, and we can do it in a strongly typed way. And that system is called model binding. And you can model bind data from the request and also validate it. So model binding is the system that allows you to take any data from the request and bind it to your action parameters. Now, by default, the model binding system will bind form data, query string values, and route values to your action parameters based off of their name. So if you have a parameter named ID and you have like a route value named ID, that'll bind just because it has the same name. If you have a query string parameter named ID, that will bind if you have a parameter named ID. So that's how that system works by default. And then you can tweak it and control it using additional attributes. For example, if you want what's in the body to be handled by MVC's formatting system, which we haven't talked about yet, but we'll get to in a second. Like you want to have some JSON data or some XML or whatever that gets handled through formatting and content negotiation, you can say this particular parameter should come from the body. You can also say that a particular parameter should come from route values, or from the query string, or from form data, or from headers using from route, from query, from form, from header attributes. Now, when you define your types that you want to model bind to, you can annotate them with data annotations, and those types will get validated. And those validation errors are made available to you. Now, validation won't prevent the request from actually landing at your action. So what you need to do is you always need to check the model state. There's a model state property on the base class that you use to see whether or not the bound data was considered valid. If it's not valid, then you need to decide what that should mean for your API. Maybe you should return a 400 bad request. Maybe you can handle that situation. I don't know, it's up to your application, but always make sure you check model state is valid. All right, let's go and try some model validation. All right, so what do we want to do here? Okay, so let's look at what is currently being bound in this application. Let me uncomment my get action. All right, so notice that we have some model binding that's already happening. Like, for example, if we look at this get action again, there's a route value called ID, and there's a parameter to the action method called ID. So the route value is getting captured and is then being model bound to that ID. That's how this value has been flowing through, and we've been seeing that throughout the demos so far. And you can do other things. Remember I said that form data, query string parameters, and route values are all bound by default. So can I bind this instead from the query string? Let's try that. I think the app is still running. If I go to values, I have to put an ID, otherwise it won't route there. But then if I say ID equals 321 in the query string, what am I going to get? Am I going to get 1, 2, 3 or 3, 2, 1? Well, it turns out that the precedence order is that route values bind first. So that particular parameter is going to come from route values in this particular case. But if we add another parameter, like let's add a string query parameter. That's not in the route, so there's no route value for it. Oh, and then we should probably display it so we can see what's happening to it. Let's say query equals query right here. And I wanted some brackets. Yeah, there we go. All right, now we save that. Let's go back. So now we shouldn't have any query string by default. We don't. But if I add, let's add query equals hello. All right, great. Now we're binding from the query string information to a separate parameter, just by name. It's just because the query string parameter had the same name. Okay, what if I really wanted this that ID to actually come from the query string? Well, I could control that. I could go in here and put a from query attribute on the ID. And now when we run this, so now the ID value is 0 because we said it shouldn't be bound from the route data, so it's not using the route data. If I add another query string parameter, like ID equals 321, then now it's working. Now it's binding from the query string parameter. Okay? All right. What about form data? So let's look at the post action. Now the post action currently doesn't do anything. Let's fix that, and let's check out what this from body model binding attribute does for us. So I'm going to switch from having just a string here, and let's actually add a type. Let's have a public class value, and let's give it an int ID. Sounds good. And then I don't know, some piece of text that we can play around with. Okay, there's our value. Let's change this from string to value. And let's see if we can now post some interesting information to this post action. And what I wanted to be able to do is I want to be able to post some like JSON data. Like JSON is the most common format used with web APIs because it's really easy to use. For example, from JavaScript, it's basically a subset of the JavaScript language. Let's try it and do that. Let's see. So let's go back into the debugger and go back to Postman and see if we can actually post a value as JSON. Oh, I did that in my put action. Oopsies. Let's go back and actually change that to post is what the one I wanted to do. Great. All right, let's run that in the debugger. And let's now go to Postman. And let's see, we want to post to /values. And now I want to send some a little bit more interesting JSON data in the request. Let's give it an ID of, doesn't really matter, like 1, 2, 3. And let's give it some text. Test will be fine. All right. And we should be able to hit this breakpoint now in post. If I send this, okay, we hit our breakpoint in our post action. If we look at this value, do we see our JSON values? We do. So that from body attribute is saying, handle the formatting for me based off of whatever configured formatters there are. In this case, it read the JSON value, gave me the ID and the text. Okay. That's cool. Now let's do this. Let's go back to our value class and let's add some validation logic. So I'm going to add a data annotation on this text property. Let's call it min length is the attribute I'll use. And I'm going to resolve the namespace. And then for the min length, let's say that this has to be 3. Yeah. Okay. So let's do that. And then inside my post action, now we have some validation. Remember, if you have validation, you need to check the model state. Don't forget to check the model state. So I'm going to put a little if check here. If model state dot is valid is false, what am I going to do? Well, for now, I'm just going to throw an exception. I'm going to throw new invalid operation exception invalid. Okay? All right, otherwise, we just let the action continue. Okay, so now if I go back to Postman, let me get this running again. Okay, so it should work, like it has to be 3, so test is longer than 3. So it should work with this request. I should get a 200. I do, but if I switch now test to just be T, it no longer has that min length of 3 characters, and send that, so now the model state is no longer valid, and I'm getting an exception. I'm getting an error, and I think we can preview what this looks. This is the developer exception page that caught that exception for us and let us know that, hey, validation failed. We threw an invalid operation exception that says that data is not valid. So that's validation occurring. And you can use all the data annotations on your model classes to specify a variety of validation rules. All right. Let's go back. All right, now throwing an exception in that case is a little unsatisfying. Let's talk about action results, how you can really have a lot of control over the response that gets sent from your action methods. So action results are used to produce the response. They're a type that derives from iActionResult. That's the interface that they implement. You can also return task of iActionResult if your action is asynchronous. And there are a whole bunch of action results that we provide for you out of the box in ASP.NET Core. Action results for setting specific status codes, action results for sending back formatted data, a whole bunch of things. And you can just new them up and just return them as an instance. But an easier way to do it actually is we provide you a bunch of helper methods on the controller base class that handle newing up the action results and flowing any context into them that they need in order to do their work. So you have to specify fewer things. So for example, if you just want to return a 200 OK from a get action that has some formatted data in the response, you can just return OK, and then specify the object that you want to be formatted in the response. If you have a bad request with some invalid data, you can just return bad request and pass in the model state, and that will automatically get serialized into the response so you can see what the model error was. That sounds useful. If you created a new resource, you can return created at action result and specify the action and some route values that can be used to generate a link to that new resource. You can return some text by returning content. You can return just some JSON by returning JSON. All these things are possible. There's a whole bunch of action results that we can play with. So let's use that now in our post action to make it better. Let's go back to code. OK, so post, instead of returning void, let's now return iActionResult. This gives us a really flexible way of controlling the response. And up here, we were returning just raw types. That basically meant we were always going to return a 200 OK with that instance serialized into the response. By returning iActionResult, we get more flexibility. For example, instead of throwing an exception when the model state is not valid, I'm going to return bad request. And I'm going to pass in the model state so that it can be provided to the client. So we can say, client, you sent me a bad request, and this was what the problem was. If the post succeeded, then actually I want to return a created at action result. So I can tell the client, yes, you got a new resource, it's created, and here's where it is. So let's see, I need to specify the action where they can get it from, and from that action, the system will create the right URI. So the action I think makes most sense would be this get action up here. And then I can specify some route values that should be passed in. So let's say you pass in an anonymous object where the names of the properties are the route values. So the ID should be what? Let's take value.id. Let's just flow that through. And then you have the option to also return some representation of the created resource right here. So I'll just return value again. So I'll just round trip it. Now normally, right in here is where you would save the value to the database or something like that. That's where the meat of the logic would occur. I'm not going to do that right now. We'll get to storage hopefully in just a little bit. Okay. That looks good. In fact, let's also update our get action so that it also returns I action result. And now, instead of returning just this static string, let's return a new value. Oh, sorry. Let's return an action result. Let's return OK, like you got it. And let's return for the thing that we return in the OK response is a new value. And let's set the ID to the ID that was passed in. And let's set the text to let's do value plus ID. Let's just do that. Okay. All right. Cool. That looks good. So now, if we run this, let's try to send a post request to this action now. Let's go back to Postman. We're going to do a post to /values. And what do we want to put in the body? Let's see. Let's look at the. Let's go back here. So now we have an invalid request to start with. Let's go ahead and send that. And we should get now a 400 bad request, but with some interesting information about what was wrong. So I think we can just send this. Let's send it. OK. And yeah, we got a 400 bad request. And now, instead of some HTML from our developer exception page, which was essentially mounted to a 500, like the server just blew up, now we're giving the client a 400 bad request. And we're telling them what was wrong. The field text must be a string or array type with a minimum length of 3. So we give some information about the validation that was done. All right. If I put the correct value in here now, like something that's longer than 3 characters long, let's see what happens. Let's send that. OK, we got a 201 created response. That was created at action result, took care of setting the right status code. And it returned a formatted representation of the thing that was created. And if I look at the headers, it also very nicely added a location header for me with the ID of the created resource. So now, if everything's wired up correctly, I should be able to make a GET request to that URI, and I should be able to get that same value. Let's see, did I get it? Let's look at the body, and I got. Yeah, my ID didn't. Oh, that's probably because I messed around with the model binding. Let's switch this back so that the ID actually bounds from the route data instead of from the query string. And let's try that again. And there it is. OK, so now we're getting ID 123 and value 123. So that looks good. OK. So that's action results. All right, let's talk about formatting. So far, we've seen pretty much JSON data being used for our web APIs, and that's very, very common, probably the most common format. It's supported out of the box by default without you having to do anything. But like we said, HTTP is all about formats. You can put anything into a request and anything into a response, and you can, in the headers, use the content type header to specify what the format is in the body. In ASP.NET Core, we use a formatting subsystem to handle request data and response data of a variety of formats. You have separate input and output formats that can deal with whatever media types you want them to deal with. You configure these formatters through the MVC options in DI. Now, the input formatters, those, of course, are going to handle the request body formats. Now, remember, don't forget to put from body on your action parameter if you want the input formatters to be used. If you don't put from body, then input formatters don't get used at all, and all you get is form data. It's the only thing that the model binding system will do. If you want the input formatters to be used, you got to put from body. Okay? Now the output formatters handle the response data, how the response will be formatted, and it does that using a feature of HTTP called content negotiation. Content negotiation is where the client can say, I would like this resource, and when you give it to me, could you please give it to me as JSON? Or if you don't have that, could you give it to me as XML? Or if you don't have that, could you give it to me as whatever you got? The server then can make whatever choice it wants about what format it actually sends back to the client. It could do what the client asked for, or it could even ignore the client and do whatever it wants. The HTTP is flexible that way. Now you can constrain which formats are actually supported by specific action methods using attributes, using the produces and consumes attributes. Produces is used to control what formats can be returned, and consumes is used to constrain what formats can be received. Now, new in 2.0, we have a new feature for APIs, is that we now support media type suffixes. So if you have a media type of the form, application/foo plus JSON, that will now get handled correctly by the system. It will be treated, for example, handled, for example, by the JSON formatter out of the box. All right, let's mess around with formatting a little bit. So we've been doing only JSON so far. Let's see if we can get some other formats. So what I'm going to do, let's go into Startup. Now in Add MVC, we have the ability here to add options. I can get access to this options object, and I can set all sorts of interesting settings, filters, conventions, and one of the things you can specify is input formatters and also output formatters. So if I have additional formatters I want to use, that's where you can specify them. Now we only wire up the JSON formatter really out of the box, but we also have XML formatters that you can use if you want to add them, but you do have to add them. I could add them individually, but we have a little helper method that makes it a little bit simpler. We can instead just say .add XML formatters, and we have two varieties of them that use two different serialization technologies. I'm going to use the data contract-based ones. Okay, let me save that. So now, if we go to, let's go to Postman, and let's just make a GET request to the values action. And as you can see, by default, we're getting JSON data. If I want something different, I should now be able to add a header to my request and say, I accept application/XML. And that should signal to the server, I would really like that resource in XML format. So let's see if that works. Yeah, and now we see we're getting XML data in the response. That preview thing did a very interesting rendering of XML, value 1, value 2. I guess it just ignored all the tags. So there's the raw XML that came back. So just because I asked for it using the accept header, that's called content negotiation. Okay? Now we can control content negotiation a little bit more. Like if we go back to our action method, and let's say for this particular action, I don't want to really ever return XML. Like this action should always return JSON. You can control that. So like for example, if I put here produces, that produces attributes, how you control the response formats that you support. And I could say this thing only produces JSON, yeah, nothing else. So let's do that and see what happens now. So now if I send that same request again where I'm asking for XML, what happens now? Now I'm getting JSON again. So the server has complete control. Like the accept header isn't a requirement. The server can still do whatever it wants. If it supports that format in ASP.NET Core, we will try to return that format. If it doesn't, it will give you just a default format. In this case, it'll be JSON. All right. Cool. And I think that's all we want to do with formats. Oh, let's show the new feature. I didn't get to show the new feature. What if we want to support a content type that uses a media type suffix? So for example, if I do this action should return Dan plus JSON. Like this is my custom media type that I defined, registered with Diana, and it is fundamentally a JSON-based format. The JSON formatting system will be able to handle that. So if we now go and say, I really would like Dan plus JSON, and we send that request, it will work. And if we look at the headers of the response, we can see that the content type is not what I wanted. Did I do that wrong? Produces application Dan plus JSON. and I said I want application dan plus JSON. That should see, what did I do wrong there? Let's try it again. There, OK, I think the server just hadn't rebuilt itself yet. So now I'm getting application dan plus JSON as the content type of the response. So that's formatting. All right. Let's talk about accessing data now. So far, we've just been playing around with data in memory, really just messing around at the HTTP layer and implementing the semantics of HTTP. But with web APIs, you're going to want to hook it up to some data at some point. How can we do that? Well, in ASP.NET Core, you can use Entity Framework Core to access a variety of data sources, both relational and non-relational data stores, SQL or whatever. And we can use Entity Framework Core as our backing data store. You create a DB context to interact with whatever data provider you're using. Could be SQL Server, could be an in-memory store, could be whatever. And then through dependency injection, you can make that DB context available to your APIs. And then when you're implementing your action methods, like that post action, you can actually write some database code using Entity Framework Core. Now, writing that code can, it's code you have to put together, and it's not terribly hard, but it can be a bit repetitive. So we actually provide you scaffolders that can generate the Web API controllers for you based off of existing DB context. And that's what I want to show you next. All right, so let's look at accessing some data. All right, so let's. I'm going to add some models to my project. Let's add a data folder, I guess is what I'll call it. And let's add, I'm gonna create a new API actually for this demo. And it's gonna be an API that just returns a list of to-do items, things to do. So I'm gonna define a to-do class. And I'm gonna give it an ID. I'm gonna give it a title, the thing to do. And let's also give it a Boolean is done property, OK? All right, so now we have our entity, the thing that we want to store. Now let's create a DB context. So I'm going to add a new class. And let's call this to-do context. That's yes. OK, so how do we create a DB context? So to create a DB context with Entity Framework Core, you derive from DB context. All right, yep, that's what we want to do. Now, when you use Entity Framework Core with ASP.NET Core, you want the DB context to be available through dependency injection. So to make that easy, we generally recommend that you add a special constructor to your DB context that should take these DB context options of the DB context type. And this just allows you to configure your DB context through DI. So I'm going to call this options. And all you have to do, you just call base and you flow the options through, and that's it. OK? And now we just define what are the database sets, effectively the tables that you want to model. So I'm going to add a DB set of to-do. And let's call this to-do. So I have basically a collection of to-dos that are being modeled by this DB context. And I think that's all I want to do. All right. To-do. Let's go now back to startup and make this DB context available through dependency injection for our API controllers. So I'm going to take services, and let's add a DB context of T. The T I'll specify as my context type. And it looks like I'm missing some using statement there. This is great. And then in here, you can specify some options. And for the options, I'm going to specify, what do I want that DB context to connect to? And that's why I added that constructor. So these options can flow into the DB context. And what do I want to do? I think I have to add a using statement to get this. Otherwise, I'm going to forget what the right method name is. I'm going to add Entity Framework Core. And I'm going to use SQL. So let's add SQL or use SQL. Yeah, use SQL Server. Great. OK, and now to use SQL Server, we need a connection string. All right, well, I think in the previous talk, Glenn probably talked about config. So let's add a constructor here. In ASP.NET Core 2, the configuration is available through DI. So I can say I configuration. Yeah, and configuration. And let's add a property here. We'll let Visual Studio help us with that. So now I've got access to configuration. And I'm going to pull out my connection string from config. And let's get the connection string, and I think the default name we always use is default connection for that connection string. All right, and that should be it. Now, I don't have a connection string in config yet. It's pretty simple to add, though. I'm going to add a config file, and we always put a connection strings in our default config files, so that makes it super easy. I think I just have to add like the name of the database I want to use. I have this database change me. I'm going to change this to web app 14 and then some random numbers. OK, cool. So that should now hook me up to my database. Let's now generate a controller. Let me build, make sure I didn't mess anything up. Oops. Where did I mess up here? So maybe not enough parentheses. Oh, I need that, and I need another parent. OK, great. And so let's add let's build. Make sure we got that right. OK, build succeeded. Now I'm going to add a controller using scaffolding. Now the first thing that scaffolding is going to ask me is like, it's going to set up my project to make sure everything's there that it needs for scaffolding. I'm going to put the minimum dependencies in. Otherwise, it'll put like layout and UI constructs, which I'm not using at all. All right, and now now that everything is set up, I should be able to actually add the controller. And I want an API controller with read-write actions using Entity Framework. So let's do that. So this will then give me a little UI where I can specify what's the model type I want to use and what's the DB context that I want to use as the basis for this controller. And then there's a little funny pluralization here. To does, I want to do's. Let's do that. All right. And that should generate for me a controller using all the routing and model binding features that we've been playing around with, but it will add all the database code that honestly I don't want to have to mess around with. Let's see, did that work? Let's take a look. So we've got a to-dos controller. It's set up to produce JSON. It's got a route. I prefer using the route template. Route tokens pattern there. So I'll do that. And then we've got a whole bunch of good code. So we've got code that's like check the model state. It'll get the values from the database, return OK. Let's look at post. Did we do post right? If we post a to-do, it checks the model state, returns bad request with model state. That looks good. Saves the changes. Those created at action. That all looks right. Let's see if this runs. Can we add some to-dos? OK. And let's go into Postman. Let's let's do a post first to see if we can add some to-dos. So API to-dos. And let's add, so this has got to have an ID. It's got to have a title. Install .NET Core, and then .NET Core 2, right? We gotta get 2. And then let's do is done is true. Should do it. OK, if we save that, not save, that should be it. Do I have any weird headers that I put in here? Let's get rid of this header, and let's send that. And should we get a 201 created? 500 server error. What? What went wrong? Went wrong. Preview. Oh, I can't connect to the database. What? Why did that happen? Well, it looks like I have a database connection problem to go to debug. That's fine. That's dealing with Entity Framework. The last thing, maybe what we could do is we can switch it to the in-memory store. That's unfortunate. We can't do the SQL one. But if we use in-memory, how about that? I think I just have to give it a name. OK. And so rerun. All right, now let's try this again. So it looks like we're running. Let's try and send an action. Is that going to work? 201 created. OK. And so now it's just being held in memory. I should be able to swap out the provider to SQL Server. I must have messed something up with my connection string. But supposedly, I created a to-do. If I do a GET request now to to-dos, let's send that. Do I see it? And yeah, it shows up in in my list of to-dos. So that's awesome. All right. Cool. So thank you everyone for following along today. I hope you enjoyed learning about building web APIs with ASP.NET Core. Here's a bunch of additional resources you can look at to learn more. Check out our docs and of course our source code on GitHub. I used Postman today. If you want to learn about generating open API specs for your APIs, check out Swashbuckle. It's a cool tool. You can also do code generation to generate clients from your open API specs using a cool community project called NSwag. Definitely check that out. And if you haven't already started, definitely go and download .NET Core 2.0 and play around with it. It's a lot of fun. Thank you for watching, and hope you have a great .NET Conf.